machine gun is one of the most iconic and deadly weapons in the history of modern warfare. Known for its ability to fire a large number of rounds in a short period of time, the machine gun has been a mainstay of military forces around the world. From World War I to modern conflicts, the weapon has continued to evolve and play a crucial role in warfare tactics. In this video, we will discuss the different types of machine guns, their history, and how they work in combat. The first use of machine guns came into popular use during World War I, when weapons such as the Maxim gun became a symbol of trench warfare. Early designs of machine guns were heavy, required several men to operate, and were often mounted in static positions. However, as technology advanced, machine guns became lighter and more portable, allowing for more flexible use on the battlefield. The first fully automatic machine gun, the Maxim gun, was invented by Hiram Maxim in the late 19th century. The gun's ability to fire hundreds of rounds without the need for manual reloading gave the troops using it a huge advantage. Other machine guns, such as the Vickers, used by the British Army, and the MG08, used by the Germans, are examples of key weapons in the war. Light machine gun, LMG. LMGs are typically used by infantry troops to provide rapid and mobile fire support. An example of a light machine gun is the M249 SAW Squad automatic weapon used by the United States Armed Forces. LMGs are lightweight and portable, capable of providing suppressive fire in rapid movement, making them often used in mobile tactical situations. Medium machine gun, MMG. Medium machine guns such as the M240 or PKM have more powerful firepower and are often used in defensive roles or for medium to long range fire. These weapons are often mounted on tripods or vehicles and have the ability to fire heavier ammunition than light machine guns. Heavy machine gun, HMG. HMGs such as the Browning M250 caliber are designed to deliver heavy firepower to lightly armored targets, vehicles, or even low-flying aircraft. These weapons have a very long range and are capable of firing large caliber rounds that pack a powerful punch. HMGs are often mounted on armored vehicles, helicopters, and warships for both cover and attack. General purpose machine gun, GPMG. GPMGs are versatile weapons that can be used in a variety of roles. An example of this weapon is the FN MAG or M240B, which is used both as an infantry support weapon and mounted on military vehicles. This versatility makes GPMGs very popular with modern militaries. Tactical use in combat. Machine guns provide a strategic advantage on the battlefield because of their ability to provide suppressive fire and stop enemy advances. In military tactics, machine guns are used to lock enemies into cover, restrict movement, or break up enemy formations. In modern combat, machine guns are often operated by small teams. A machine gunner will target the enemy, while a support team provides additional ammunition and secures the surrounding area. The use of machine guns in teams allows for effective offensive and defensive maneuvers. As technology has advanced, machine guns have undergone several improvements. One of the biggest innovations was improved cooling systems, including liquid and air cooling, which allowed machine guns to fire more rounds without the risk of overheating. In addition, improvements in materials technology have made machine guns lighter and more powerful. Optical and electronic systems have also been integrated into modern machine guns, allowing shooters to lock onto targets with greater precision, even at night or in adverse weather conditions. Smart bullets and computer-based targeting systems are the next step in the development of machine guns, providing greater accuracy and efficiency on the battlefield. The machine gun is a symbol of power and efficiency in modern warfare. How machine guns work, the mechanism behind their deadly firepower. Machine guns are one of the most iconic weapons in military history, known for their ability to fire large amounts of bullets automatically. In general, machine guns work on the principle of automatic fire. This means that the weapon can fire continuously as long as the trigger is pressed and ammunition is available. This mechanism relies on several key components, including the chamber, barrel, and trigger system, all of which work in sync to allow for repeated reloading, firing, and firing. Main mechanisms of machine guns. Machine guns consist of several key systems that allow for automatic fire. Power source blowback, gas-operated or recoil-operated. The primary way machine guns operate their next round of ammunition comes from one of three systems blowback. In a blowback mechanism, the pressure from the gases generated by a fired bullet is used to push the bolt locking block back. This then ejects the spent cartridge and inserts a new bullet into the chamber. This system is generally used on small to medium caliber weapons. Gas operated. In this system, some of the gas produced from the shot is directed to the piston or gas cylinder to push the bolt back. Examples of weapons with this mechanism are the M249 saw and M240B. The gas-operated system allows for more efficient reloading, especially on larger caliber weapons. Recoil-operated. The recoil-operated system uses the force of the recoil after the bullet is fired to move the bolt. Weapons such as the Browning M250 cal use this mechanism because the recoil is strong enough to cycle automatically. One of the key features of a machine gun is the ability to automatically load the next round into the chamber after the previous round is fired. This process involves a feed system mechanism, which can be a magazine, belt-fed, or drum. Belt-fed machine guns such as the M240 or M2 Browning use a belt-fed system, where ammunition is stored in a long bundle of bullets. The belt is automatically fed into the machine gun and is cut as the round is fired. Magazine-fed. Some machine guns, such as the M249, can be operated using standard magazines or using a belt-fed method. Trigger system. The trigger system serves as the primary control for initiating fire. When the trigger is pulled, the firing pin is released, striking the rear of the bullet and igniting the explosive inside. This produces a small explosion that forces the bullet out of the barrel. Once the round is fired, the reloading mechanism begins the process of chambering the next round, ensuring that the cycle of loading and firing continues as long as the trigger is held down. Firing cycle. A machine gun functions through a process called the firing cycle, which involves 5 basic steps. Firing. The bullet is fired when the trigger is pulled and the firing pin triggers the explosion inside the cartridge. Recoil or blowback. The energy generated by the firing from recoil or gases drives the bolt rearward. Ejection. The rearward movement of the bolt ejects the empty cartridge from the chamber through the ejection port. Reloading. A new cartridge is drawn from the magazine or belt-fed cartridge and inserted into the chamber. Locking. The bolt moves forward and locks the cartridge in place, preparing it for firing again. This cycle occurs in a matter of seconds and can be repeated hundreds of times as long as the weapon has ammunition and the trigger is depressed. Cooling. Because machine guns can fire a large number of rounds in a short period of time, an effective cooling system is essential to prevent overheating. There are 2 primary methods of cooling machine guns. Air cooling. Air-cooled machine guns use natural airflow to keep the barrel temperature stable. The barrel design is usually finned to increase surface area and speed up the cooling process. Liquid cooling. Liquid cooling systems are less common in modern machine guns, but some models, such as the Maxim gun, use water to cool the barrel. Rate of fire and accuracy. The rate of fire of a machine gun varies depending on the model. Some machine guns can fire as many as 600 to 1,200 rounds per minute. However, despite their high rate of fire, recoil control is critical to ensuring accuracy. Most machine guns have a bipod or tripod that is used to stabilize the automatic firing. The machine gun is one of the most complex and deadly weapons on the modern battlefield. Its ability to fire continuously and automatically is based on complex but efficient technical principles such as automatic reloading. Harnessing energy from recoil or gas and cooling systems in combat, machine guns provide tremendous firepower, allowing troops to lock on and stop the enemy quickly and effectively.